Greetings everyone. Toyota Prius. When you hear this, I'm sure the first feature that popped into your head would be that it's one of the most common hybrid vehicles in the world. Yeah, that's how synonymous Prius became as a hybrid vehicle through all these years. One has to realize this is a time when hybrids have slowly started to become mainstream in many countries. But let us try to look at this from a different perspective. Let's try to travel back in time to 1997 and visualize how the perception would have been towards hybrid cars. If you probably ask someone around this time the question of what they think of hybrid cars, they would describe something futuristic which would be on the roads many years down the line. But Toyota was about to change all that with their first hybrid vehicle later that year. Toyota very aptly named it Prius, which literally translates to ahead of its time in Latin, and becoming the first mass-produced electric hybrid car in the world. I am Midhun, and I am going to attempt to dissect the different parts of this vehicle from an electrical standpoint. This video is towards the fulfillment of the first assignment in the EHV subject as part of the M.Tech Automobile Engineering course. Toyota Prius is a series parallel type of hybrid electric vehicle. It combines the advantages of both the basic hybrid configurations, being the series and the parallel, while introducing several complex power flows possible with such a setup. Let us look at these different power flows briefly before going any further. Firstly, there's the stop condition, where the motor and the engine are off. This prevents any fuel consumption while the conventional vehicles do idling at places like traffic lights. Next, the start condition. Here, only the motor starts off, providing the entire power straight from halt with its much superior lower end torque, again improving fuel consumption in the case of start-stop city traffic. At low speed condition, the engine remains shut off as engine efficiencies are lower at such speeds and the motor is enough to handle the power requirements. When there's a need for a higher acceleration, the engine kicks in and supplies the additional torque required, while the motor continues to assist the engine in this mode. In normal running condition, the engine and the motor keep running based on the power required, and the generator uses the additional power to charge the high voltage batteries, thus ensuring minimum wastage of energy. When the driver brakes, the engine is turned off and the traction motor switches into regeneration mode, where the power from the wheels is fed back to the HV battery, charging it. These are the different modes in which the car operates throughout its drive cycle. Unlike conventional vehicles, the inclusion of a high voltage battery allows for more voltage levels to be used in the vehicle, and accordingly, we see 4 different voltage levels in Toyota Prius: 12 volt DC, 650 volt AC, 201.6 volt DC, 27 volt AC. The 12 volt DC being the traditional voltage level used for auxiliary loads, as we see in most of the conventional vehicles, 650 volt AC, which is used by the motor drive, 201.6 volt DC used by the HVAC, the HVAC system, and 27 volt AC used by the power steering system. Coming to the application of these voltage levels in the car would require us to split the various electrical loads into resistive, inductive and capacitive, and determining the approximate ratings which help in understanding the total power to be generated. This leads to the following results. We get power windows which are inductive and have a rating of 12 volt and a maximum current rating of 15 amperes. The AC compressor, this is a 3-phase motor, induction motor to be exact, which runs at a rating of 201.6 volt DC, and this is an inductive load. Then there's the heater, which is used for heating the catalytic converter so that it runs at the optimum temperature, which is a resistive load again. Then we have the windshield wipers, which are inductive. They have a rating of 14 watts. Then we have the headlamps, which are again resistive with a 12 volt and 55 watt rating. And the front fog lamps, again resistive with 12 volt and 55 watt rating. Then we have the rear view mirror motors, which are inductive, again at 12 volts. The seat adjustment motors, which are inductive, again at 12 volts. The central infotainment console, this, if you are using a touch screen, you could probably put this under the capacitive section. Then we have the power steering motor, which is an induction motor rated at 27 volts and 6 amperes nominal current, and again this is an inductive load. Now there also exists two active loads, that is the two motor generators which are used in the vehicle. The first motor generator is a 3-phase 50 kilowatt PMSM, that is a permanent magnet synchronous motor, and this works as the ISG. This is again inductive. ISG stands for integrated starter generator. Then we have the motor generator 2, which is a 3-phase 60 kilowatt PMSM traction motor, and this is inductive. So this is the main traction motor of the vehicle. Now all these different voltage levels and loads mean that there's got to be a way to transfer power to and from between these different power levels. This is analogous to how power reaches our households from generating stations by stepping up and down voltages. The DC equivalent of this is done using DC to DC converters, also known as choppers. Toyota Prius uses two such choppers to switch between different voltage levels, and these choppers also allow bidirectional power flow. Then there's the need for converters which can switch between AC and DC voltages. This is achieved using inverters. These allow the two AC PMSM motors to run off of the HV batteries. These, along with the power steering motor, means 3 inverters in total are used in the vehicle. Toyota Prius also uses a AC-DC converter, which is also termed as a rectifier, which is used to charge the batteries internally. Apart from this, there's also a plug-in version of Prius which was released in 2012, and this adds another rectifier, making the car capable of charging via our household wall outlets at 120 volt AC. Coming to the energy source, we have a 168 cell 1.2 volt high voltage battery pack, which adds up to 201.6 volt capacity. It is a nickel metal hydride chemistry battery. It has a capacity of 6.5 ampere hour. This battery was selected by Toyota considering the cold climate countries, as nickel metal hydride chemistry is better suited for lower temperatures. Toyota also released a version later based on lithium-ion chemistry with a 56 cell 3.6 volt battery pack, adding up to the same 201.6 volt. This also made the charging circuit a lot easier, since it is much easier to work with lithium-ion compared to nickel metal hydride batteries. Then there's the standard 12-volt lead-acid battery, which powers the auxiliary circuits such as the lighting and infotainment systems. Finally comes the alternator. Now, this being a hybrid vehicle means it doesn't exactly require a standalone alternator coupled with the engine. Instead, Toyota Prius uses an integrated starter generator which is coupled to the engine. As the name suggests, it can act as an engine starter as well as charge the high voltage and low voltage batteries while the engine is running, or when the engine is idling. It's a 50 kilowatt 400 Newton meter rated PMSM machine. Then there's the traction motor mounted on the front. This is also a PMSM machine and powers the front wheels with a maximum torque of 72 Newton meter. On applying the brakes, it can also regenerate energy and recharge the high voltage batteries. Now I'll sign off with some interesting facts about Toyota Prius. The nickel metal hydride battery of the 2002 Prius, when compared with the 2011 Prius when it came out, it was found that the old battery performance matched the new one. Just goes to show the reliability of the battery pack. When the car released in 1997, it became the first engine to work on the Atkinson cycle, after which many manufacturers followed suit. Due to the higher voltages available in the car, Toyota was able to pack in drive-by-wire technologies back in their second generation Prius in 2003. First, it is the first fully electric brake-by-wire system which was included in a car. Also, development of Toyota Prius between 2004 and 2009 resulted in 530 patents being filed by Toyota. Thank you all and have a nice day.